So let's state the domain of the following functions. So this is going to be all x such that this makes sense. So this guy, what's the domain equal to? So I should really do this as an answer. So the domain here, well, we can only take square roots of non-negative numbers, so 0 inclusive onwards. Multiplying by 2 doesn't affect anything, so the domain is equal to exactly the same as the ordinary square root. This guy, well, the domain is exactly the same. What about the last one? The last one, it's the same basic story, except we have one extra kind of kink, which is we don't want to divide through by 0. So in this last case, we have to be careful. We can't include 0, and that only happens at 0, so it would be that onwards. Now, are they increasing or decreasing? So this is kind of more difficult. What should we do? Well, first of all, we need to check the conditions, right? And I think many of us looking at this will be thinking, well, it would be really nice if we could see the graph, wouldn't it? If I can see the graph, then basically I can just look to see, does it move upwards as I move the input to the right? But I don't want to rely on the graph. I want to make sure I truly understand the definition. So the definition basically says the function preserves inequalities. At least if it's increasing, and if it's decreasing, it reverses them. So let's just see what happens. So first of all, let's have a less than b. A less than b, and let's say greater than or equal to 0. So this is me dealing with the first and second case, I think. So this implies, of course, we can take square roots. We know by our basic rules of how inequalities work, our algebra for inequalities, we know that the square root of a, we've just seen this, is less than the square root of b. So roots preserve the inequality. And finally, well, it's 2. Well, if I multiply by 2, it doesn't affect anything because it's positive. So this implies that 2 root x is increasing. We've checked it from first principles. Any two guys in the domain, a and b, if I feed them into the function, the inequality is preserved. Right, and that's because 2 is positive. Well, first of all, because roots preserve inequalities, and then because multiplying by 2 preserves the inequality and 2 is positive. Now, the negative is a different story, right? It's almost exactly the same, except you're suddenly going to switch, aren't you? So what's going on there? Shouldn't have that. So in this case, well, if I take negative of both sides, what does it do? It's going to turn it around. That's the same as multiplying by -1. So that means it reverses the inequality. What does that mean? It's decreasing by definition. Quite tricky. Finally, the last case. It's the same story. We get to here. But I need to be a bit careful here because in the last case, we can't allow 0. So let's remove that possibility. So that's true. It's also true now that taking the square root gives you a non-zero number. So this is the case. Yeah? But if I take two positive numbers, one less than the other, and I take the reciprocal, so 1 over both of them, that reverses it. This is one of my basic rules about how inequalities work. So this implies what? Well, 1 over a, 1 over root a, is now going to be bigger than 1 over root b. So it reverses the direction of the inequality. That and that are the opposite way around. So that tells you it's a decreasing function because it works for any inputs. So this exercise really is designed to make you understand that it's not really enough mathematically just to look at something and say, oh, look, it seems to be going down. If you want to really do things precisely, you've got to check them algebraically, which means looking at the actual meaning of what increasing and decreasing is. And the meaning of that is in terms of inequalities. It's not to do with slopes or anything like that you may have heard of in high school. That's related, but only once you've studied calculus. But it's not the same, right? Increasing and decreasing is to do with preservation or not of inequalities.